This is part 2 of the video, Introduction to Exercise 7.1 on the topic of integration. Here are the 5 functions that we can integrate. So first one is algebraic function, second one is exponential, third one is logarithmic, fourth one is trigonometric, and fifth one is inverse trigonometric. So we will solve 2 problems from each, 2 or 1 problems from each functions. So first we'll go with algebraic functions. There are certain conditions for algebraic function to apply integration. So if I have a function x to the power n, and if I integrate with respect to x, I will get the integral as x to the power n plus 1 divided by n plus 1 plus c. If I integrate 1 with respect to x, I'll get x plus c. So here I have 1. So if I integrate 1, I'll get x, because differentiation of x is 1. There are 2 types of problem in exercise 7.1. One is find integral by method of inspection. And the second method is using the formula. So it will be starting with find the integral. So if the question is use the method of inspection, we have to inspect by using differentiation. And the second problem is find the integral, we have to just apply the formula. So we'll solve 2 problems here. Okay, so first one, using method of inspection. So 3x square plus 4x cube. This is using method of inspection. So we need to find the function that differentiate to give this function. So this is the answer for now. So 3x square plus 4x cube. So I need to differentiate some function to get 3x square plus 4x cube. So we know that differentiation of x to the power n is n times of x to the power n minus 1. n into x to the power n minus 1. So to get 3x square, I should have 3x cube. To get 3x square, I should have x cube. And to get 4x cube, I should have x to the power 4. So we know that finding antiderivative is integration. So 3x square plus 4x cube. Antiderivative of this will be x cube plus x to the power 4. Second problem, find the integral. Find the integral of x cube minus 1 divided by x square. So here we are going to apply the formula. So integration of x cube minus 1 divided by x square with respect to dx. So we know that we can apply the formula when the function is x to the power n. So when the function is x to the power n. So it should be individual term. So it can't be like this. It can't be the term which has the combination of x cube and the numerator and x square in the denominator. It should be a separate term. So we are going to separate it. X cube by x square minus 1 by x square. So we know that's the basic fractions. So when we have common denominator, we can add or subtract the numerator. So we have split it into two separate fractions. So now we can simplify x square. So remaining 1 x will be there. And this 1 by x square can be written as x2 to the power negative 2. Because we need to have x to the power n in the numerator, and it should be a separate individual term or separate. So now we can integrate. So integration of x to the power negative 2. We are going to apply the formula. When we use the formula, you will get the integration. You will get the integral as x to the power n plus 1 divided by n plus 1. So x to the power 2 divided by 2. Here x to the power negative 1 divided by negative 1. So if I simplify that, I'll get x square by 2. So this negative and this negative will become positive. So plus x to the power negative 1. So I can simplify further. X square by 2 plus this x to the power negative 1 can be written as 1 by x. That's a law of indices. So I have to include integration constant plus c. So that's our final answer. Second one is exponential function. So we have a formula. If I integrate e to the power x, I'll get e to the power x plus c. The same formula what we have followed in differentiation. So we are going to follow method of inspection. First problem, e to the power 2x. So method of inspection. So to get e to the power 2x, what should be the function to differentiate? I have to differentiate that. So we know that this is a chain rule. So to get e, if I differentiate e power x, I will get e power x. But here I have e to the power 2x. So if I differentiate e power 2x, I'll get e to the power 2x, and I have to differentiate this index part or the power part. So if I differentiate 2x, I'll get 2, and I have to write as a coefficient. So 2 into e to the power 2x. But in our problem, there is no 2 in front of e to the power 2x. So I have to eliminate that 2. I have to eliminate this 2. So my function should have 1 by 2 to eliminate that 2, and it should be e to the power 2x to get e to the power 2x. So this is the function. So opposite, if I integrate e to the power 2x with respect to dx, I'll get 1 by 2 e to the power 2x. This is method of inspection. Second problem, find the integral of 4 e to the power 3x plus 1 with respect to dx. So we need to integrate. So we can separate it. 4 e to the power 3x plus 1 dx. So if I integrate for e to the power 3x, I'll get e to the power 3x, and the 4 is a constant. So 4 e to the power 3x, but I have to differentiate that, and I have to write it in the denominator. In the differentiation, you have differentiated the power and written in front of e to the power 2x, but here I have to differentiate, then I have to write as a denominator. So differentiate 3x, you will get 3 and write it as a denominator. Then if I integrate 1 dx or integration of dx, I will get x plus c. Next, logarithmic function. Logarithmic function, the formula for 1 by x dx will give you log of mod x. So if I differentiate log x, we know that differentiation of log x will give you 1 by x, and we know that differentiation of log of minus x will give you 1 by negative x, and if I log x is 1 by x, so that log of negative x is 1 by negative x, and I have to differentiate inside, that's negative 1. So you will end up with 1 by x. So if I differentiate log of x, I am getting 1 by x, as well as if I differentiate log of negative x, I am getting 1 by x. So both the case I am getting 1 by x. So I can write this as differentiation of log modulus of x, because it includes positive and negative of x, gives you 1 by x. So again, antiderivative, so 1 by x, integration of 1 by x with respect to dx will give you log of modulus x plus c. In this case we used method of inspection, so there is no need of c. So final function is trigonometric function. So there are some formulas for trigonometric functions. There are some identities for trigonometric functions. So I'm going to write everything here. Okay, these are all the formulas for trigonometric functions. So integration of cos x, integration of sin x, integration of secant square x, integration of cosecant square x, integration of secant x tan x, integration of cos x cot x. So these are all the integration formula, and we know some formulas of trigonometric identities. That's a reciprocal identity, Pythagorean identity, and ratio identity. So we are going to use all these formula in integration of trigonometric function. So kindly go through this. We are going to use this. Example problem, first one, we are going to use method of inspection. So sin 2x minus 4e to the power 3x. So this is method of inspection. So we are going to differentiate some function to get sin 2x minus 4e to the power 3x. So differentiation of cos x is sin 2x. So I have 2x here, so cos 2x. So if I differentiate cos 2x, I'll get 2 sin 2x, because differentiation of cos 2x is sin 2x, and I have to differentiate this 2x to get this 2. But in this function I don't have 2. So So I have to remove the 2. I can use 1 by 2 here. So next is 4e to the power 3x. So obviously e to the power 3x will be there. And here I have a constant 4. So I have to include that 4. So when I differentiate e to the power 3x, I will get e to the power 3x into 3. But here I don't have the 3, so I have to include 3 in the denominator. I have a negative sign. So this is how we have to inspect, then have to find the answer. So finally, integration of sine 2x minus 4e to the power 3x gives the answer as 1 by 2 cos 2x minus 4 by 3 e to the power 3x. So if you practice a lot, method of inspection will be easy. So second problem. Find the integral of secant x in the bracket secant x plus tan x. So we can simplify that. So secant square x plus secant x tan x. We'll go through the formula again. Integration of secant square x is equal to tan x plus c. And the next formula we are going to is integration of secant x tan x is equal to secant x plus c. So integration of secant square x plus integration of secant x tan x dx. You will get integration of secant square x is tan x. Integration of secant x tan x is secant x. So when I integrate secant square x, I will get one c here. When I integrate secant x tan x, I will get another c here. So if I add these two c's, I will end up with one constant. So I can use that as 1c. So another problem. Integration of secant square x, integration of cosecant square x. So we have to simplify because we don't have integration of secant square x and cosecant square x as a formula. So I need to simplify that. 1 by cosecant square can be written as 1 by cos square x. 1 by cosecant square x can be written as 1 by sin square x. These two formulas are reciprocal identities. So 1 by cos square x and 1 by sin square x. So I can bring cos square x to the denominator. If I bring sin square x to the numerator, I'll get sin square x, and cos square x, 1 by cos square x to the denominator, I'll get cos square x. So we know that sin square x divided by cos square x as tan square x. But still I don't have formula for the integration of tan square x. I have a formula for integration of secant square x we have used in the last problem. So I'm going to change the tan square x as secant square x. So secant square x minus 1 dx. So if I integrate secant square x, I'll get tan x. If I integrate the negative 1, I'll get negative x plus c. So inverse trigonometric function we will see in the next exercise. So for now we have seen trigonometric function, logarithmic function, exponential function and algebraic function. Thank you.